Okay, today I am going over the Unit 5 Part 1 review to get you ready for your test. It starts off giving this table to you that has some important information on it. One thing I would like to add is about our axis of symmetry, and that is the formula x equals the opposite of b over 2 times a. Okay, so number 1 asks us to identify the vertex and the focus of this equation. So if I ever want to find the vertex, I always start off with the axis of symmetry formula. So I'm going to come over here and find my axis of symmetry formula using x equals the opposite of b over 2 times a. Now if you don't know, a is in front of the x squared, b is in front of the x, and c is the constant. So when this formula tells me to take the opposite of b, it's asking me to take the opposite of negative 12. And the opposite of negative 12 is a positive 12. Then it wants me to divide by 2 times my a. Well, a is 2, so it wants me to take 2 times my a, so 2 times 2 is 4. And if I divide 12 by 4, I get 3. So that is my axis of symmetry. And it is also the x-coordinate to your vertex. So the axis of symmetry and the x-coordinate to the vertex are always the same. Now I just need to find the y-coordinate of my vertex. So to find the y-coordinate of my vertex, I can do a few different things. But what I'm going to do is I'm going to put this equation into y equals of my calculator, go to the table, and look for a 3 in the x column. Okay, and there are other ways to do that, but this is what I'm going to do. All right, so I'm going to go to my y equals, and I'm going to type this equation in. 2x squared minus 12x plus 19. And then I want to go to my table and look for a 3 in the x column. So second graph, and searching for the 3, and across from it, I see a 1. And so that's the y. Okay, so I now know my vertex is 3, 1. So if I look at my answer choices for the vertex, I realize that answer choice A is incorrect because it has negative 3, 1. Okay, so now it's either B, C, or D. Okay, so next thing it wants me to find is my focus. So I'm going to look at this box up here to find the formula, and this is my formula for my focus. Okay, before I do that, one thing you need to make sure you know. The x-coordinate of the vertex is the h, and the y-coordinate of the vertex is the k. Okay, so when the focus says it's h, then you look to see who the x-coordinate of your vertex is, which is 3. So it's going to be comma 3. Then it wants me to take my k, and my k is a 1, and add to that 1 divided by 4 times a. So this wants me to take 4 times a. So remember, your 2 is your a, and it wants me to take 4 times that. So 4 times 2 is 8. So now I just need to clean up this focus. I know that 1 plus 1/8 is 1 1/8, but you might not know that. So I'm going to go to my graphing calculator, and I'm going to type 1 plus, and I can enter 1/8 several different ways. I'm going to use alpha y equals though. So alpha y equals, I'm going to choose number 1. I'm going to put 1 on top, arrow down, put 8 on bottom, and when I hit enter, I get 9/8. So my focus is 3, 9/8. And so if I look for that answer, I see it. Bing, bing, bing. Answer choice B. Okay, next one up. Number 2. It says, identify the quadratic function graphed below. Well, I know since the graph is opening down that my a is negative. And if you didn't remember that little tidbit, come up here and look at this table. It shows you that if a is bigger than 0, meaning if a is positive, the graph opens up. And if a is a negative number, then the graph opens down. So I know that since the graph opens down, the A is negative. So let's just look at those answer choices. A is in the very front, and I need it to be negative. Look at answer choice A. A does not have a negative in the front, so A is out. Okay, there are different ways to do this as well, like there are lots of problems, but I'm going to just graph the answer choices and see if it matches the picture. So let's try that. So I'm going to graph answer choice B. So negative x squared plus 4x, and I'm going to hit graph and see if it looks like this picture. And it clearly does not. This is on the right side of the y-axis, and this is on the left side, so can't be B. Okay, let me try answer choice C. So it has negative x squared minus 4x. Okay, let me hit graph. Okay, without looking really closely, that looks pretty good. Let's look at answer choice D. So answer choice D has a negative parentheses, x plus 4, close the parentheses and square it. Let me hit graph. And that's definitely not it. So it must be answer choice C. Okay, next one up. Says determine whether this equation has a maximum or a minimum. And then we're going to find that value. All right, so this all depends on our A as far as whether it's a max or a min. So remember, A is the number in front of the x squared. And if A is a negative number, the graph opens down. If a graph opens down, the vertex is the highest point of the graph, making it a maximum. So I need this to say maximum. So who can we get rid of? We can get rid of A and we can get rid of D. All right, so whether a graph opens up or opens down, the lowest point, which would be called a minimum, and the highest point, which is called a maximum, take place at this thing called the vertex. So if you ever want to know the max or the min, you need to find the vertex. So any problem that ever says something about finding the max or the min, that's going to be the vertex, because the vertex is always the lowest point of the graph if it opens up, and it's always the highest point of the graph if it opens down. Okay, so max and min problems mean find the vertex. So I'm going to do what I did on problem number 1, and I'm going to start with that axis of symmetry formula. X equals opposite of B over 2 times A. So if I take the opposite of B, I'm going to take the opposite of a negative 10, and the opposite of a negative 10 is a positive 10. Then I'm going to divide by 2 times my A. So I want to take 2 times my negative 5, and 2 times my negative 5 is negative 10. And if I divide 10 by negative 10, I get negative 1. So that is my axis of symmetry. It is also the x-coordinate to my vertex. So every time you get the axis of symmetry, you have also found the x-coordinate to the vertex. Now I just need to find its y. Okay, so I am going to do what I did earlier. I'm going to put this equation in y equals, and I'm going to look for negative 1 in the table. Okay, so let's put our equation in. So go to y equals and type it. We've got negative 5x squared minus 10x plus 6. So the guy in the front's a negative, the guy in the middle is a minus. Negative 5x squared minus 10x plus 6. Okay, then I'm going to go to my table, second graph, and I'm going to look for negative 1 in the x column. And here it is, and across from it is an 11. So this is my vertex. And I know the y value is the answer that I want. Whenever you're asked for a max or a min, you want to know how high something is or how low something is, and high and low is a y value. So that means my max is 11. So that makes it answer choice B. All right, number 4. We're going to solve this by factoring. And if exact roots can't be found, we'll state the consecutive integers between which the roots are located. Okay, well, when I solve by factoring, it needs to say equals 0. And when I factor, I like my x squared to be positive. So I'm going to leave that x squared alone. And I'm going to move the 6x by subtracting it. And of course, if you do it to one side, you have to do it to the other. So this side would just be x squared minus 6x. And this side is now a 0 because you subtracted the 6x. So once it says equals 0, then you can begin solving by factoring. Okay, the first rule of factoring is to look for a GCF. And this has one. Lots of students forget that it does, but it does. Both of these guys have an x. So we need to factor out the GCF, which is an x. So now I need to figure out what goes in here. So when you distribute, you get x squared minus 6x. So x times what makes x squared? Well, x times x makes x squared. And x times what makes negative 6x? Well, x times negative 6 makes negative 6x. And then I'm going to bring down my equal 0. Now, if I could factor what was in parentheses, I would, but I can't. Whenever you have two terms, you want to see if it's a difference of squares. Well, it's a difference, but 6 is not a perfect square, nor is x, because it has to have an even exponent. So I'm done factoring. So once you get it factored, you take your first factor and set that factor equal to 0. And then you take your second factor and take that and set it equal to 0. And then you just solve these equations. Well, this equation's already solved because x is by itself, but this equation we need to solve. So to get rid of subtraction of 6, I do the opposite, which would be to add 6. And 0 plus 6 is 6. So my answers are x equals 0 and x equals 6, which is answer choice D. Okay, number 5 is another solve by factoring. So first, make sure it says equals 0, and it does not. So I like my x squared to be positive, so I'm going to leave this side alone. I'm going to make this side a 0. So to get rid of a positive 28, we have to subtract. So that will leave me a 0 on the right, and then you can't actually combine any of those because none of them look alike. So we drop it, drop it, drop it. So I drop the x squared, I drop the minus 3x, and I drop the minus 28. Now I'm going to factor this. So first rule of factoring, like I said earlier, is to look for a GCF. But there is no GCF. There's not an x that they all have, and nothing can go into 1, 3, and 28 besides a 1. So then when I count that there's 3 terms, 1, 2, 3, I take a times c, and I do this little rooftop. So 1 times negative 28 is negative 28. And then I want the numbers to add to make the b, which is negative 3. So I'm looking for two numbers that multiply to make negative 28 and add to make negative 3. Now, some of you are good at this and some of you not so much. If you need your calculator's assistance, you take what you want your numbers to multiply to be and put divide by x in the y equals of your calculator. So what you want the numbers to multiply to be divided by x. Then go to your table and be searching for the numbers across from each other that add to make negative 3. Ignore decimals, and here they are. Bing, 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 bing. 4 and negative 7 add to make negative 3. So those are the ones I want. So because it's the 1 in front, it's the easy one. So I get to go straight to the answer. I put the letter the problem is working with in the front, and I write down the numbers I found, positive 4 and negative 7 in the back. And then I just need to bring down my equal 0. Well, once you get it factored, you have to set your factors equal to 0. So I take my first factor, x plus 4, and set that equal to 0. And then I take my second factor, x minus 7, and set that equal to 0. And then I just need to solve those two equations. Now, these equations are really simple to solve in your head, but if you need to see it, to get rid of addition of 4, we subtract. So 0 minus 4 is negative 4. To get rid of subtraction of 7, we add. And 0 plus 7 is 7. So my answers are negative 4 and 7. And that is answer choice A. So there were two that we had to solve by factoring. And just remember that they need to say equals 0 before you can factor. They need to say equals 0 before you graph also. If they don't say equals 0, then they need to say equals y. So make sure that they say equals 0 or equals y. And if they don't, you got to fix it. Okay, let's move on. Okay, question 6. This wants to know which quadratic equation has roots 7 and negative 2/3. Well, roots are your solutions. Another word for solutions are your zeros. And another word for that are your x-intercepts. So when a problem asks for you to find the roots, it's asking for you to find the solutions, the zeros, the x-intercepts. All of those words mean the same thing. So the easiest way to do this would be to graph your answer choices and see which ones touch the x-axis, because that's what x-intercepts do. They touch the x-axis at 7 and negative 2/3. Now, I do need to make sure that these all say equals 0 before I put them in the calculator. And because they do, then they are ready to graph. Okay, so let's look at answer choice A. So I'm going to type answer choice A in, 2x squared minus 11x minus 21. I'm going to hit graph and see where it looks like it touches the x-axis. Okay, now I need it to touch at 7 because I want the zeros to be 7 and negative 2/3. This looks like it could be a 7. Let me go to the table. And if it is a 7, sure enough, you're going to see a 0 in the y column. Okay, so that one's good. Now, negative 2/3, this looks like this is somewhere between negative 1 and negative 2. If I look at the table, I'm not going to see it because there's no decimals in the x's. But remember, 0 happens between where a positive number and a negative number occurs. So I know the other answer is somewhere between negative 1 and negative 2. Well, is negative 2/3 between negative 1 and negative 2? And if you don't know, you could put negative 2/3 in your calculator and ask yourself, is this between negative 1 and negative 2? And it is not. So it can't be answer choice A. So A's out. Okay, let's just look at C, since C happens to be right there. Okay, so I'm going to type that in. 3x squared minus 19x minus 14. Okay, let's hit graph. Now that looks like another 7, so let's see. And sure enough, 7 is an answer because there's a 0 in the y column. Now the other answer was a decimal, so I know it's going to happen somewhere between here and here, because 0 happens between where a number goes from a positive to a negative. So I know the other answer is between 0 and negative 1. Well, is that between 0 and negative 1? It is. So right now, answer choice C is looking like it's really good without doing a lot of extra work. Let's just see if we can rule it out. Let's try answer choice B. So answer choice B has 3x squared plus 23x plus 14, and I'm going to hit graph. Now, this does not look like a positive 7, so it cannot be answer choice B. And let's look at answer choice D. So answer choice D, we have 2x squared plus 11x minus 21, and if I hit graph, once again, this is not a positive 7, so it can't be that. So, yep, answer choice C ended up being the one we wanted. All right, number 7. These parentheses are not smushed together. They are separated. So when they're separated, you look for something in the front to distribute and something in the middle. Well, there's nothing in the front to distribute, so I'm just going to recopy that without the parentheses. So 15 minus 13i. But I do have something to distribute here, and it's a negative, or you can think of it as a negative 1. So a negative times a negative makes a positive, so that's a positive 1. And a negative times a positive makes a negative, so that's a negative 17i. So when you combine like terms, you're going to combine your real numbers first. So 15 plus 1 is 16. And then you're going to combine your imaginary numbers. And a negative 13i and a negative 17i add to make a negative 30i. And that is answer choice A. So adding and subtracting numbers and i's is really easy. It's just the real number goes with the real number and the imaginary goes with the imaginary. Okay, now number 8 requires a little more work. So I'm going to actually do this on a different piece of paper here where I have a little more space to work. All right, so I can't have this I in the denominator. So I am going to multiply by what looks like the denominator with a sign change. So instead of 2 minus, it's going to be 2 plus 3i. And I need to multiply in the form of 1, so it's got to be the same thing over itself. So this will get rid of the I in the denominator. Okay, so looking at this problem, I'm going to work the numerator, and then I'm going to work the denominator. So the numerators are smushed together. So I'm going to FOIL this out or double distribute. So I'm going to take 1 times 2, which is 2. I'm going to take 1 times 3i, which is 3i. Then I'm going to distribute the 2. 2i times 2 is 4i. And 2i times 3i is 6i squared. So you're foiling here or double distributing. So you distribute the 1 times both things in the back, and then you distribute the 2i times both things in the back. So I'm going to go ahead and just clean this up. So I squared, do you remember? That's something special. I squared has a value of negative 1. So every time you see an I squared, you're going to replace it with negative 1. So this is telling you to take positive 6 times negative 1. Well, positive 6 times negative 1 is negative 6. So now I'm going to combine like terms. So I'm going to combine the real number with the real number. So 2 minus 6 makes negative 4. And then I'm going to combine the imaginary with the imaginary. And 3i plus 4i makes 7i. And it's positive, so I'm going to put plus 7i. Okay, that is my numerator. All right, now I need to work my denominator. And I know I'm not working this out very nicely, so I apologize. So I'm going to do my denominator now. So when I multiply my denominator, I can do the same thing. I am going to FOIL this out or double distribute this out. So I'm going to take 2 times 2, which is 4, and then 2 times 3i, which is a positive 6i. Then I'm going to distribute the negative 3i. So negative 3i times 2 is negative 6i, and negative 3i times positive 3i is a negative 9i squared. So you distribute 2 times both things in the back, and then you distribute negative 3 times both things in the back. Now let's clean this up. So every time you see an I squared, you want to replace that with a negative 1. So this is really telling me to take negative 9 times a negative 1, which is a positive 9. So now if I combine like terms in my denominator, I'm going to combine my good-looking numbers first, my real numbers first. So 4 plus 9 is 13. So I'm going to come up here and put a division bar. So 4 plus 9 makes 13. And then I'm going to combine my imaginary numbers. And a positive 6i minus 6i makes 0. So this is my answer. It's not very pretty, but that's him. Now, when you look at the answer choices, they don't quite look like that. So which one do you think it looks like? D. So all D does is it takes this number and puts it over the denominator, and then it takes the second number and puts it over the denominator. So D is the same thing as what I got. Okay, so Basically, you cannot have an I in the denominator. So if you have addition or subtraction attached to the I, what you're going to do is you're going to multiply by what's in the denominator, except with the sign change. So if this is a minus, you'll multiply by 2 plus 3i over 2 plus 3i. If this would have been 2 plus 3i, then you'd multiply by 2 minus 3i over 2 minus 3i. So you're going to multiply by what's in the denominator with the sign change. Okay, number 9. We already did this once today. Determine whether this equation has a maximum or a minimum. So first, let's talk about a. A is a number in front of the x squared. This time, our a is a positive number, which means that this graph opens up. And a graph that opens up, does it have a max or a min? It has a min. The vertex would be the lowest point, so it's a minimum. So I know that that rules out A and C. Okay, so to find this minimum, I need to find the vertex because that's where the minimum occurs. All right, so to find the vertex, I'm going to start off with my axis of symmetry formula. X equals opposite of B over 2 times A. So when I go to take the opposite of B, I'm taking the opposite of a negative 20, and the opposite of a negative 20 is a positive 20. Then I'm going to divide by 2 times my A. So when I take 2 times A, I'm taking 2 times 5, and 2 times 5 is 10. And when I divide that, I get 2. All right? So that's my axis of symmetry. It is also the x-coordinate to my vertex. I just now need to find the y. Okay, so I'm going to put this equation in y equals and go to 2 in the x column of the table. So going to my calculator, I'm going to type that equation in. 5x squared minus 20x plus 3. I'm going to go to my table, and I'm looking for 2 in the x column. There he is, and it's a negative 17. So remember, the y value is the answer we want when we're looking for a max and a min, because max and min want to know how high or how low something is, and a y value is what tells you how high and how low. So negative 17 is the minimum, which means it's answer choice D. Okay, let's look at number 10. So number 10 is like number 7. These parentheses are not smushed. If they're not smushed, you look for something in the front to distribute and something in the middle. There's nothing in the front to distribute, so I'm going to drop the 10 plus 5i. Just lose the parentheses. And there's nothing in the middle to distribute. If this was anything besides a positive 1, I'd have to do it. But positive 1 times anything changes nothing. So I'm just going to drop all this. So plus 1 minus 21i. Okay, so those parentheses were just there to trick you. But don't let them trick you. Be smarter than that. So now we combine real number with real number. So what's 10 plus 1? 11. And then we're going to combine imaginary with imaginary. So a positive 5i minus 21i makes a negative 16i. And where do you see it? Answer choice C. Bing, 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 bing. Okay, now number 7 is a different story because the parentheses are smushed. If parentheses are smushed, we're going to FOIL or double distribute. If parentheses are not smushed, then you just look in the front and middle for something to distribute. Okay, so when I distribute this, I'm going to first distribute the 7, and I'm going to multiply it with both numbers in the back. Okay, so I'm taking 7 times 5, which is 35. Then I'm taking 7 times negative 13i. So 7 times negative 13i makes a negative 91i. Then I'm going to distribute the 6i with both things in the back. So I take 6i times 5, and that is a positive 30i. And then I'm going to take 6i times a negative 13i. And if I take 6i times a negative 13i, that's a negative 78i squared. Remember, I times I is I squared, just like x times x is x squared. Okay, but every time I see an I squared, I need to replace it with a negative 1. So this is really telling me to take negative 78 times a negative 1. And a negative 78 times a negative 1 is a positive 78. So that just becomes a positive 78. Now I'm going to do what I did in the last problem. I'm going to combine the real number with the real number. So I'm going to take 35 plus 78, and that makes 113. And then I'm going to combine the imaginary with the imaginary. So I'm going to combine a negative 91i plus 30i. So negative 91 plus 30 makes a negative 61. So it's a negative 61i. And do you see it? Yep, it's answer choice D. Okay, I'm going to stop the video here, and then I will resume with number 12.